Welcome guys. So this is question 5.22 of chapter 5, and the statement of this question is, according to a genetics theory, a certain cross of guinea pigs will result in red, black and white offspring. Okay, so let me underline them: red, black and white offspring in the ratio of 8:4:4. Find the probability that among 8 offspring, 5 will be red. Okay, 5 will be red, 2 will be black and 1 will be white. Okay, so this is clearly the problem of the multinomial probability. So in multinomial probability, let me write the formula for finding out the probability for the red equal to 5, black equal to 2 and white equal to 1. This is what? This is basically the total items, which are 8. Okay, so total items factorial divided by the number of red items factorial multiplied by the black items factorial and white items factorial multiplied by the probability of the red items which are here and raised to the power 5 which are here. Similarly, the probability of the black items raised to the power 2, because these are the items here. Okay, and similarly multiplied by the probability of the white items raised to the power 1, which is here. Okay, so now here it is clear that in order to find out this probability, we have to find out the individual probabilities of red, blue and white. So therefore, let me write here, let me use this blue color here. So the probability of red is what? This is the number of red divided by the total number of the items. Okay, so here from this ratio we can very clearly see that the total number of items or the total number of things here are 8 plus 4 plus 4, and this is 16. Okay, so n of t is 16, while the ratio of the red items or red guinea pigs is 8. Okay, so this is the first item, so therefore it would be 8. So this is clearly 0.5. Similarly, for the black guinea pigs, we have to write the black guinea pigs divided by the number of the total number of the guinea pigs. So from here we can see that these are 4. So 4 by 16, this is 0.25, and also the probability of the white guinea pigs, this would be the NW, number of the white guinea pigs divided by the total number of guinea pigs. So again from the same formulation we can see that this is 4 over 16, which is 0.25 as well. Okay, so let me write here all the values. So it would be 8 factorial divided by 5 factorial multiplied by 1 factorial is 1, 2 factorial is 2, so multiplied by 2, and here writing the values of p of r, which is 0.5, so 0.5 raised to the power 5, 0.25 raised to the power 2 and 0.25 raised to the power 1. Okay, so from here what would I get? It would be 8 multiplied by 7 multiplied by 6 multiplied by 5 factorial divided by the 5 factorial multiplied by 2. These two will cancel out. Similarly, it would be 236. Okay, and here we would get 0.5 raised to the power 5, and also these are the similar items, so 0.25 raised to the power 3. Okay, from it when I will solve it, ultimately I will get what? It would be 0.084, and that is what? That is basically the solution of our question, which is related to the multinomial probability, and this is the solution of this thing which you wanted to find out, and it is here. So that's it for today, in which we have seen the solution of question 22 of chapter 5 of our book. So this is question 5.23 and 5.24. Many times people are confused between multinomial probability and binomial probability. So in this video, I will try to demystify this concept by solving question 5.23 and 5.24, which are relevant, but one question is related to the multinomial probability theorem, while the second one here is the binomial probability law. Okay, so I will try to relate them and demystify the concept of the both probability distribution. So let us first start it from question 5.23. So the statement of this question is the probabilities are 0.4, 0.2, 0.3 and 0.4 respectively that delegate to a certain convention arrived by air, bus, automobile or train. Okay, so let me also write it here. So let me represent the air with A, bus with B, automobile with AU and train with T. So these are what we have, and their probabilities are also given here. So let me write their probabilities. Okay, so these are all the probabilities. What is the probability that among 9 delegates randomly selected at this convention? Okay, so the total number of delegates, let me represent it with N, and that is 9. 3 arrived by air, 3 arrived by bus, 1 arrived by automobile and 2 arrived by train. And here we can see that we have 4 classes, class A, B, AU and T. And in order to find out the probability that the items from the first class are 3, okay, this is here. Items for the second class, which is bus, are 3 again. Items for the third class, which is automobile, it is 1. So AU is 1. And the last item, that is train, this is 2. We can see that here we have 4 classes, and in order to find the probability of this combination, what do we have to do? Here you have to keep in your mind that we will have to use the multinomial probability, because we have here multi items. So in order to do it, I will have to use the formula n factorial divided by the number of a's, a factorial, b factorial, au factorial and t factorial, and then multiplying with the probabilities these has. This is the probability of A multiplied by the probability of B, multiplying it with the probability of AU, okay, and also with the probability of what? Probability of T. So these are what we have. Also, after multiplying the probabilities, I have to write their powers as well. So the power of it will be A, the power of P of B would be B, power of P of AU would be AU, and the probability of this last term will be T. So let me put all these values here. N is 9 here. So 9 factorial divided by A is 3. 3 factorial multiplied by 3 factorial, B is 3. This is 1 factorial, and the last item here is 2. So 2 factorial. And now with them, let me multiply the probabilities. For the first item, I have 0.4 raised to power 3. Okay. P of B is 0.2 raised to power what? This is also 3. P of AU is 0.3 raised to power 1. And the last item P of T is, that is 0.1 raised to power 2. Okay, so we can see here that, let me represent each item with different color. This is A, we have to write it here, and this is also written, the relevant term is here as well. Okay, for the second item, let me represent it with yellow. this is B, B is here, okay, and the relevant probability it has is here, okay. The third item here is, let me use this color for it. The third item is here, it is here, okay, and the relevant probability it has is here. And the last term here, let me represent it with this brown color. So this is here, it has this t factorial, and the relevant probability it has is here. So it is very easy to see and find out all these probabilities and all these items, and we will get the answer out of them. And keep in your mind that this is the n factorial, which are basically the total number of items. So this is for the multinomial probability. In order to see that what's the difference between the multinomial and binomial probability, let us go through the question, which is 5.24, and the statement of this question is, a safety engineer claims that only 40% of all workers wear safety helmets when they eat lunch at their workplace. Assuming that this claim is right, find the probability that 4 out of 6 workers randomly chosen will be wearing their helmets while having lunch at the workplace. So in order to write it, let me first write here the given data. So probability that an engineer wears a helmet while at lunch, this is what? This is 0.4, and let me represent it with P of H. And from it we can see that the probability that he doesn't wear a helmet while lunch, this is what? This is 1 minus 0.4, so this is 0.6. So let me call it probability of H prime, okay. So now we can see that we have two classes. Wherever I will have two classes, there I have to use what? I have to use the binomial probability, because of the bi term, which means 2. Here we have multi classes, so wherever I will have multi classes, so in order to find out the probability of the all independent events, I have to use the multinomial probability, because of the term multi, which means many. Okay, so in order to find it out, we have to do what? I have to find out the probability that we have total items here are n equal to 6, and out of these 6, 4 items are here. Okay, so I have to find it out, which if I see is basically k equal to 4, and this is what? This is basically the n factorial divided by, with it I have to write k factorial and also n minus k whole factorial, and then the probabilities associated with them. So the probability that k person wear the helmet while having lunch, this is basically probability of H raised to the power k, and also the probability of H prime, okay, which doesn't wear the hat, this is n minus k. Let me put these values. So now n is 6 factorial divided by k factorial is 4 factorial, and minus k is 2 factorial, and the probabilities they have are 0.4 raised to the power 4 and 0.6, which is for H complement, this is square. So finding them out, I will see that I will get the probabilities of the item. Here you can see that this is the first item of the person we have the helmets, and this is the second probability. Let me use this blue color. This is the second item and it has the probability here. So generally I can also write it here as well. Let me choose the color, this one as well. So it would be the n factorial divided by class 1 factorial multiplied by class 2 factorial, and the probability of class 1 raised to the power class 1 multiplied by the probability of class 2 raised to the power class 2, which is similar to this one, just here in case we have two classes which are here and here. Okay, so this is basically the difference between these multinomial and binomial theorem. You can find out the answer of them by using the calculator. This is question 5.25 of chapter 5, and the statement of this question is: suppose that for a very large shipment of integrated circuit chips, the probability of failure for any one chip is 0.10. Okay, so let me write the given data here. So given data, let me write it with this blue color. The probability of failure is what? This is given, and this is 0.10. Assuming that the assumptions underlying the binomial distributions are met. It is already given that we are going to use the binomial distribution. Find the probability that at most 3 chips fail in a random sample of 20. Okay, so the random samples or the total number of items here are 20, and we want to find out the probability that the number of failure are at most 3 chips, means failures are less than or equal to 3. We have to find it out. Okay, so let me solve them here, and in order to solve them here we have to use what? Let me use the formula for it, and the solution of it is here. I want to find out the probability of failure which is less than or equal to 3. Okay, so in order to find it out, this is what? This is all the items which basically lies in this range are the probability that we have 0 failures plus the probability that we have only one failure plus the probability that we have 2 failures and plus the probability that we have the number of failures equal to 3, because at most we must have 3 failures. So the formula for it we are going to use is, let me have here the probability that the number of failures are k. This is what? This would be n choose k, and the probability of success is k and failure is n minus k. Okay, so here this p is p of f, this small n is this capital N, and this k, this is here all the items here. So for each of the item here we have to apply this formula. Okay, for each one of them, for this and for this as well. So therefore, in order to find out the probability that f is less than or equal to 3, we have to apply the similar formula for k is equal to 0, up to 3, and here we will have to apply and choose k. Okay, p of f will remain the same, raised to the power k, and here we will have 1 minus p and minus k. So 1 minus p of f, okay, and minus k. So applying it here, what would I get? I will have here n choose 0. Okay, and here it would become 1 because this is 0 and 1, and here we will have 1 minus 0.10, so we will have here 0.9 raised to the power n minus 0, so n minus 0 would be n. Okay, plus for the second item we will have n choose 1, p of f is 0.1, so 0.1 raised to power 1 and 0.9 raised to the power what? This would be n minus 1. Okay, plus n choose 2, 0.1 raised to power 2 and 0.9 n minus 2 plus here and choose 3, 0.1 raised to power 3 and 0.9 n minus 3. Okay, for all of them we have n equal to capital N, which is 20. Okay, you have to put all these values here. So let me move down somehow. So here ultimately we will get what? We will have here 20, choose 0, and here 0.9. Okay, and here 20 plus 20, choose 1, 0.1 multiplied by 0.919 plus 20, choose 2, 0.1 square and 0.91 plus 20, choose 3, 0.1 cube and 0.9. 3 minus 3 would be what? This would be 0. So raised power 8 will be 1. Okay. So finding them all here, so it would become 20 factorial divided by 20 minus 0, because you can see here that A choose B is always equal to the A factorial divided by B factorial and A minus B whole factorial, applying them all here. So ultimately from all of them together you will get what? Here you will get the probability that the failures are less than or equal to 3. So you will have the amount, let me call it x, and that would be the answer of our question. So I have told you how to apply the concepts here, how to get the answer, and whatever we have here would be the answer we have. Okay, so that's basically the solution of the question 5.25. This is question 5.26, and the statement of this question is: assuming that 6 in 10 automobiles accidents are due mainly to a speed violation, find the probability that among 8 automobile accidents 6 will be due mainly to a speed violation. Okay, so we have to do it how? In part A of it, we have to use the formula for binomial distribution for finding out the solution, and B, we have to solve it by using table A.1. Okay, so let us solve it here. So the solution of it is here, and in order to solve it, we can very clearly see that here we have 8 choices, and out of those 8 choices we have 6 which should be true, or which should be the accidents which we want to find out. Okay, so first we have to find out what? We have to find out the probability of accidents. Why? Because this is clearly the problem of the binomial probability distribution. Okay, so according to the binomial probability distribution, if I want to find out the probability of x equal to k, this is what? This is the n choose k. Okay, the probability of the each item or each success here, so it would be the probability or p raised to power k and 1 minus p raised to power n minus k. Okay, looking at it here, what information did we get? We can very clearly see that here we have found that 6 in 10 automobile accidents are due mainly speed violations. So from it we can very clearly find out the probability of these automobile accidents which are due mainly to a speed violation, and that is 6 out of 10, which is 0.6. Okay, this is what we have found out. Similarly here we can very clearly see that among 8 automobile accidents, 6 will be due mainly to a speed violation. So the total number of automobiles here are 8, and from 8 we have to find the probability that 6 are basically due mainly to a speed violation. Okay, so all the items are given here. Let me put values here. So the probability that x is equal to 6, okay, or probability that k is equal to 6, that can be written here as well. Okay, so putting all these values here, we will get 8 to 6. Probability is 0.6, 0.6 raised to power 6, okay, and 1 minus 0.6 raised to power 8 minus 6, that is 2. Let me simplify it as well. So simplifying it, it will become 8 factorial divided by 8 minus 6 factorial, which is 2 factorial and 6 factorial as well. Okay, multiplying it with this 0.6 raised to power 6 and 0.4 raised to power 2. Okay, solving it, at the end what will we get? The answer of it, finding them all here, the answer of it would be 0.2081. Okay, so that is what, that is basically the solution for part A of my question. Okay, let me write here part A as well. So this is the solution of part A. Similarly, in part B, we are asked to find the similar solution by using table A.1. Okay, so what is the table A.1? How can we find out the values here? So here we have all the values, which is for n equal to 8, and the probability here is what we can see, that this is 0.6. This is, let me have here part B. In order to find out the probability for k equal to 6, what do we have to do? We can very clearly see that we have to find out the probability of all the items less than or equal to 6, and from it I have to subtract the values which are less than or equal to 5. Okay, why this? Because if I can see here that this is the distribution, here I have the 6, here I have 5, okay, and I have here this distribution, let me have it for this 6, okay, and I want to find out what? I want to find out this area which is here. So from this I have to subtract this area, which let me highlight in red. Okay, so in order to do so I have to subtract this area. Okay, so this area is what? This is this, okay, and this bluish area, which is the overall, this is here. Okay, so from it we will very easily find out this area, which is the required one, and this is here we have. But what table do we want to find out? Why did I use this k less than or equal to 6 and k less than or equal to 5? Why not we simplified it by using this formulation? Let us first go to the table A.1. So this is basically the table which we were here to use. So now here you can very clearly see that this is the formula which I am going to use, and here for my previous question where I have k is equal to 6, for it I have used probability that k is less than or equal to 6 minus the probability that k is less than or equal to 5. Why? Because here you can see that here we have this symbol which is less than or equal to c. So here we have c equal to 6, here we have c equal to 5. So this is the first parameter I have to use here. This is the first parameter I have to use it. Okay, similarly the other parameter here I have to use is the n. Okay, so n is what? N is basically the total number of items which are here. So the total number of items here which I have previously seen are 8. So this is the second parameter here as well. Okay, the third parameter is this probability, which I have seen that this was 6 by 10, so which was 0.6, which I have previously seen. So this was here 0.6, 0.6 here as well. Okay, so I have to find out the probabilities of these parameters and then subtract them out. But how to find them out here? The first parameter here is 0.6. Let me choose this color here. Okay, so the first parameter here is the 0.6, so this is here, so I have to look at this column. Okay, this is the table, and the second parameter is n equal to 8. Okay, this, so here these are all the values of n. This is n equal to 1, 2, 3, 4. Okay, so let me move to the n equal to 8. Okay, so this is n equal to 8, and the third parameter here is what? This is here 6 for this one and 5 for this one. So let me move here. This is 8, and the values for the third parameters are here. So the first is here, the second one is here. So let me use them here. This is for the first one, let me use this blue color. Okay, so the first one is this one. The probability of it was 0.6 and this was 0.685. Okay, so the for 5 it is 0.685, and from it I have it should be subtracted from this one where the value of C is 6. So let me move to the same position, and here I can see that let me use another color for it, and for it let me use this green color. Okay, this green color. So this is 6 and this one, so this is 0.894. so this is 0.894. okay, so once we will subtract them, what will be the answer? The answer of it would be, let me use another color which is this black. The answer of it would be 0.209. okay, which is what? Which is basically the solution of the question which I wanted to find out. Okay, this is 0.209, and I have explained this table to you because this is the binomial probability equation, and you have seen that how to use this table for it. This n is basically the total number of items which are here. This C is what? This is basically the 6 and 5 which are basically found for the ranges which we have here, and the last item here is the probability, which is the probability of the true events for which we have here all the required stuff. Okay, so let us move to our page. So this is what we had, and here we have found out that this was what? This was 0.209. okay, which is what? Which is almost the same value which we have found out by this formula, but the methodology for finding out the probability by this method is quite different than this one. But you have found out that how to utilize the binomial probability table to find out the required quantities. Okay, this is question 5.27. And the statement of this question is, if the probability that a fluorescent light has a useful life of at least 800 hours is 0.9, find the probabilities that among 20 such lights, party of it, exactly 18 will have a useful life of at least 800 hours. B, at least 15 will have a useful life of at least 800 hours, and C, at least 2 will not have a useful life of at least 800 hours. Okay, so this is basically the statement, and now we have the table as well as the formula to solve them. So in this question we will try to solve it by using the table which we have instead of falling into the heavy calculations. So in this question, let us first write the given data here. So in writing the given data, this is the given data. Okay, so what is given? We know that the probability that life of a fluorescent light is at least 800 hours. So this is greater than 800 hours. The probability of it is given, and that is 0.9. Okay. So let me call it the probability P of the true event. Similarly, here we have the total lights, which are n equal to what? 20. Okay, this is what we are given. Now on the basis of it, what do we have to find out? We have to find out, or the required quantities here are, okay, in part A we have to find what? We have to find exactly 18 will have a useful life of at least 800 hours. So we want to find out the probability that k is equal to 18. Okay, B is the probability that at least 15 will have a useful life of at least 800 hours. So at least means, okay, greater or equal to, so k should be greater or equal to 15, which is at least, and maximum is 20 because the total number of items there are 20. So this is required. And in part C, we have to find out that at least 2 will not have a useful life of at least 800 hours. So at least 2 will not have means the probability that the useful lives will be less than or equal to 18. Why? Because 2 is the lowest range of the not working lights. Therefore, 18 is the maximum range of useful lights. Okay, so therefore, I have written it like this. So now, this is part A. So let me solve it first. The solution of it is here. And in order to find it, we have to find the probability that k is equal to 18. Okay, and this is what we need to use the formula, which is here, and k, okay, p, which is the probability 0.9, this is k, and also 1 minus p n minus k. So let me remove them and write 18 here. Okay, so 18, and also the value of n is 20 as well. So this is 20, and it would be 20 minus 18. So here it would be 20, sorry, 18 and 2, and the p value is 0.9. So let me write it here as well, the 0.9, removing it, and it will become 1 minus 0.9. So 0.9 raised to power 18 and 1 minus 0.9. So this is what we have. When you will follow it, you will find the answer, which will be equal to what? 0.2852. Okay, so this is one method which we have seen here. Another method, which is based on the tables here, we can find out the probability that k is equal to 18. This can be found out by using the table, and for that we will need what? We would need probability that k is less than or equal to 18, and from it I have to subtract the probability that k is less than or equal to 17. Okay, so now we now know that here, in order to find this value from the table, we have to find out the probability that the value of n is 20, k is, or let me make it more specific, c is 18, and the probability is 0.9. Okay, from it I have to subtract this, where n is again 20, C is 17 and probability is 0.9. I have to take both of these values and subtract them together. So let me take these values and go to the table here. So this is the table which I was using. So let me use it here, and for it, this is what the probability is, which is 0.9. Okay, the value of n is what? The value of n is 20. So let me move to the 20. Okay, so this is what we have, 20, and here these are the values for the probability 0.9, because this is basically the second last column, and the two probabilities which we want to find here are for c equal to 18 and c equal to 17. Okay, for c equal to 18 we have here this one, so this is 0.608, and the second one is here 0 point, which is for 17, less than or equal to 17, this is 0.32323. So let me take them and and move them here. So it is 0.608 minus 0.323. So the answer of it is 0.285, which is what? Which is the similar one which we had here, and that is what? That is basically the solution by tabular form, which is a similar one as it is here. Okay, so this is the solution for part A. Now in order to solve part B of my question, let me use this color as well. So this is B, and probability that I want to find out the probability that K is greater or equal to 15. But now this calculation will be very heavy. In order to do so, I'm going to use the table. So therefore, in using the table, I have to convert this symbol into the less than or equal to. So it would become 1 minus the probability that K is less than or equal to 14. Okay, or it would be 1 minus, I have to find out the probability where the value of n is 20. Okay, the probability is 0.9 and the value of c is 14. Okay, and I had to subtract it from 1. So let me go to the table again. So here we have a table, and let me choose another color for this question. So this is 14. This is what? This is for 0.9 probability. This is because this is the second last column, and the value of c is 14. So this is 0.011. So let me take it and put it there, 0.011, and subtracting it, what I will get? 0.989, and this is what? This is basically the solution for part B of my question. Okay, so this is the solution for part B. Now in order to solve part C, let me move down somehow. So in part C, I have to find out the probability that K is less than or equal to 18. So again, this is a very hefty calculation. The other way I can do it, I can use it like 1 minus probability that K is greater or equal to 19, or it would become 1 minus the probability that K is equal to 19 plus the probability that K is equal to 20. Okay, finding them again by using the formula, which is the binomial formula for the K value of 19 and 20, adding them together and subtracting them, I will get the answer. But if I have a table, I can directly find out the value for k is less than or equal to 18. So now here I have to find out the formula in which the value of n is 20, probability is 0.9, and the value of c is 18. Okay, so this is what we have to find out. So let us move to the table again. This is the table, and here I have to find out the value for 18, and this is here which I had. So this is 0.608. So now 0.608, and that is what? That is basically the solution of part C of my question. Okay, why did I not change it to or not subtract it from 1? Because this one is already less than or equal to 18, and I have previously told you that in this formula, in this table, I must have to use this one, and you can see that I have here less than or equal to C. So I have to convert all these values into this form. Okay, so now this one is already in that form. So that's it for today, in which we have seen the solution of question 5.27 and how to use the probability table, which can reduce the computation time and also give you the answer in the minimum time as well. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon.